The Haliade-X 12 megawatts is a powerful offshore wind turbine developed by GE Renewable Energy, notable for its significant contributions to renewable energy technology. The nacelle, which is the housing that contains all of the generating components in a wind turbine, including the generator, gearbox, drivetrain, and brake assembly, is one of the most crucial parts of this turbine. Transporting the nacelle to Rotterdam is a critical phase in the deployment of these turbines. Rotterdam, with its extensive port infrastructure, serves as a key hub for such large-scale industrial operations, facilitating the assembly and installation of offshore wind farms. The 12 megawatts version of the Haliade-X is one of the largest and most powerful wind turbines in the world, capable of generating enough electricity to power thousands of homes, marking a significant step toward reducing carbon emissions and advancing global energy sustainability. The arrival of the nacelle in Rotterdam is likely part of the process of assembling these turbines for use in offshore wind farms, where they will contribute to the generation of clean, renewable energy on a massive scale. The video illustrates the construction of the Roßkopf wind farm in the Spessart region, a significant milestone in Germany's renewable energy landscape. This project is a collaborative effort involving GE, Nature Energy Main-Kinzig, and GE Renewable Energy, each bringing specialized expertise to the table. The development of this wind farm in a challenging environment like the Spessart showcases the growing capability of the renewable energy sector to integrate clean energy solutions into diverse and environmentally sensitive areas. The Spessart, a mountainous and densely forested region in Bavaria, Germany, is renowned for its natural beauty and ecological significance. This setting provides both opportunities and challenges for wind energy development. The elevated terrain and frequent wind currents make it an ideal location for wind energy generation, as the turbines can capture more consistent and powerful winds. However, the dense forests and rugged topography complicate the logistics of transporting and assembling large turbine components. Additionally, the project had to be carefully planned to minimize environmental impact, preserving as much of the natural landscape as possible, while ensuring the stability and efficiency of the wind farm. GE, a leading German renewable energy developer, spearheaded the Roßkopf wind farm project. Established in 1996, GE has built a reputation for successfully developing wind, solar, and bioenergy projects worldwide. For the Roßkopf wind farm, GE was responsible for selecting the site, conducting environmental assessments, securing permits, and overseeing the construction. Their expertise ensured that the project met high environmental and technical standards while integrating renewable energy into a region known for its natural beauty. Nature Energy Main-Kinzig, the regional energy provider, commissioned the project and will manage the energy generated by the wind farm. The company is dedicated to sustainable and environmentally friendly energy production, aiming to reduce reliance on fossil fuels and lower carbon emissions in the region. Nature Energy Main-Kinzig's involvement highlights the critical role of local energy providers in the transition to renewable energy, as they are instrumental in distributing clean energy to communities and ensuring that the benefits of such projects are locally realized. The wind turbines for the Roßkopf wind farm were supplied by GE Renewable Energy, a global leader in wind energy technology. GE's turbines are known for their efficiency, durability, and ability to perform in diverse environmental conditions, making them a suitable choice for the Spessart's challenging terrain. The selection of turbines for this project was based on a thorough analysis of the site's wind patterns, topography, and environmental constraints, ensuring that the wind farm operates at optimal efficiency while minimizing its ecological footprint. The construction of the Roßkopf wind farm involved several intricate phases. The initial phase required site preparation, including the careful clearing of areas for turbine installation while preserving the surrounding forest. Building the foundations for the turbines was a complex engineering task, given the uneven terrain. Transporting and assembling the turbine components through the narrow, winding roads of the Spessart presented additional challenges, requiring specialized equipment and techniques. Once assembled, the turbines underwent rigorous testing before being connected to the regional power grid, marking the final step in bringing the wind farm online. The Roßkopf wind farm is a significant achievement in Germany's renewable energy journey, demonstrating that with careful planning, advanced technology, and strong collaboration, large-scale wind energy projects can be successfully integrated into even the most challenging environments. The time-lapse video captures the impressive installation of GE Renewable Energy's Haliade-X, the world's most powerful wind turbine, at the port of Rotterdam in the Netherlands. This monumental feat of engineering showcases the assembly of a turbine capable of generating 12 megawatts of power, a capacity that translates to enough energy to supply 16,000 European homes annually. The video highlights the intricate process of constructing the Haliade-X, from the careful positioning of its massive components to the final assembly of the towering structure. Standing over 260 meters tall with 107-meter-long blades, the Haliade-X is a symbol of innovation and efficiency in the renewable energy sector. Its installation at Rotterdam, a key hub for wind energy development, marks a significant milestone in the ongoing transition to cleaner, more sustainable energy sources. The project not only underscores GE Renewable Energy's commitment to advancing wind power technology, but also demonstrates the potential for large-scale renewable energy projects to meet the growing demand for electricity in Europe and beyond. The Haliade-X turbine is expected to play a crucial role in future offshore wind farms, where its immense power-generating capacity will contribute significantly to reducing carbon emissions and advancing global energy sustainability efforts. Bellevue is one of the most prominent and heavily trafficked locations in Zurich, Switzerland. As the primary hub for the Zurich public transportation system, known as VBZ, it sees a staggering amount of daily activity. Every day, around 75,000 people pass through Bellevue, either transferring between various modes of transportation or arriving at their final destination. In addition, approximately 60,000 vehicles navigate this area daily, making it one of the busiest intersections in the city. Together with the Quai Bridge, Bellevue is considered one of the most critical transportation nodes in Zurich, seamlessly connecting different parts of the city and serving as a vital link for both commuters and travelers. In 2015, Bellevue and the adjacent Quai Bridge became the focal points of one of Zurich's largest and most ambitious construction projects in recent history. The scale of the project was immense, and its significance was underscored by the necessity of maintaining Zurich's infrastructure at a high standard, particularly in such a heavily used area. The project aimed to replace all the tracks on Bellevue Square and the Quai Bridge, which had become extremely worn out due to the constant heavy traffic. The existing infrastructure was showing signs of age, and the renewal was not only necessary, but also urgent to ensure the safety and efficiency of the transportation network. The preparation for the project began well before the actual construction started. Preliminary work kicked off in March 2015, allowing the project team to plan meticulously and coordinate with all stakeholders involved. Given the importance of Bellevue and the Quai Bridge in Zurich's transportation system, it was crucial to minimize disruptions and ensure that the work proceeded smoothly and efficiently. The main construction work commenced immediately after the Sechselauten Festival in mid-April. Sechselauten is a traditional spring festival in Zurich, and the decision to start the major construction right after this event was strategic, as it minimized the impact on one of the city's significant cultural celebrations. From the outset, it was clear that the project would be complex, requiring precise coordination and flawless execution. One of the most significant challenges of the project was the replacement of the tracks at Bellevue and on the Quai Bridge. The tracks were heavily used and had suffered extensive wear and tear over the years. Given the high traffic volume, the tracks were critical for the smooth operation of the public transportation system. Their replacement was essential to maintain the reliability and safety of Zurich's transportation network. The track replacement involved laying 1,750 meters of new track, installing 3 new lubrication systems, 19 switches, and 4 new track extensions. The installation of these new components was a massive undertaking, requiring the use of advanced technology and skilled labor. Over several weeks, the project team removed 3,500 cubic meters of demolition material, which was a significant task in itself. In its place, they brought in 800 cubic meters of recycled material, demonstrating a commitment to sustainability and resource efficiency. Additionally, 1,600 cubic meters of concrete was used to ensure the stability and durability of the new tracks. During the first major weekend of track replacement, more than 400 workers were involved in the project. The sheer number of workers on site highlighted the scale of the operation. These workers represented a wide range of skills and expertise, from engineers and construction workers to logistics coordinators and safety officers. The collaboration and teamwork were essential to ensuring that the work proceeded according to plan, especially given the tight timelines and the need to minimize disruptions to the city's transportation network. The project was not just about replacing the tracks. It also involved making significant improvements to the infrastructure at Bellevue. Due to its heavy usage, the existing tracks were extremely worn out, necessitating a complete overhaul. The new tracks were designed to be more durable and better suited to the high levels of traffic that Bellevue experiences daily. Additionally, the stops at Bellevue were modified to make them more accessible for people with disabilities. This was an important aspect of the project, as it aligned with Zurich's broader goals of creating a more inclusive and accessible public transportation system. The city's civil engineering office also took the opportunity to carry out additional improvements in the area. The Quai Bridge, which plays a crucial role in the city's transportation network, was refurbished as part of the project. This included structural repairs and enhancements to ensure that the bridge could continue to support the high levels of traffic it experiences. Moreover, 2 new station roofs were installed at the theater and Rami Strassi stops. These new roofs were designed in the same style as the historic rotunda in the middle of Bellevue, preserving the aesthetic continuity and historical significance of the area. The construction process was meticulously planned to minimize the impact on the city's transportation system. The project team was acutely aware of the importance of maintaining traffic flow, especially given Bellevue's central location and the high volume of daily commuters. The construction was divided into several phases, with the most critical work taking place during 2 weekends in July. These weekends were chosen to minimize disruption, as traffic levels were slightly lower during this period. During these 2 weekends, the construction site was a hive of activity. The old tracks were removed, and the new ones were laid in a process that required precision and efficiency. The construction site operated like a well-organized machine, with every task carefully choreographed to ensure that the work progressed smoothly. Despite the tight schedule and the complexity of the work, the project was completed on time. One of the key reasons for the project's success was the intense preparation and planning that went into it. The project team worked closely with various partners and suppliers to ensure that all aspects of the construction were coordinated effectively. This level of coordination was crucial, given the number of different tasks that needed to be completed simultaneously. The collaboration between the different teams was a testament to the professionalism and expertise of everyone involved. Safety was also a top priority throughout the project. Given the central location and the high levels of traffic, it was essential to ensure that the work was carried out safely and that there were no accidents or incidents. Thanks to the rigorous safety protocols and the experienced teams on site, the project was completed without any accidents, which was a significant achievement given the scale and complexity of the work. The project also involved extensive communication with the public, particularly with the residents and businesses in the area. The project team understood the importance of keeping people informed about the work and its potential impact on their daily lives. As a result, they carried out an intensive information campaign, which helped to minimize disruptions and ensure that everyone was aware of the work being done. This proactive approach to communication paid off, as there were very few complaints or issues raised by the public during the construction period. Despite the challenges, the project was a resounding success. All major events in Zurich were able to proceed without interruption, even with the construction taking place in the heart of the city. This was a testament to the careful planning and execution of the project, as well as the professionalism of the teams involved. Before the end of the summer holidays, all the new tracks and traffic routes had to be thoroughly tested to ensure that they were ready for use. On the Friday before the resumption of the tram service, test runs were conducted on all the new tracks using the complete rolling stock of the VBZ and the Forchbahn. These tests were critical to ensuring that the new tracks were safe and ready for regular service. The central station in Zurich, a critical transportation hub, serves as a focal point for city transit, accommodating approximately 45,000 passengers daily. This centrality underscores the importance of the station's recent renovation project, which was undertaken in the summer of 2017. The project aimed to replace the tram tracks and renew the roadway surface, marking a significant and complex undertaking for Zurich's public transport authority, Verkehrsbetriebe Zurich. The renovation involved laying approximately 1,450 meters of new tram tracks, installing 13 new switches, and renewing 7 intersections. Additionally, the 4 tram stop platforms were updated to enhance functionality and accessibility, and the bike lanes were improved to better accommodate cyclists. These changes were not merely functional, but also aimed to create a cohesive visual and operational unit, transforming Central from a busy transit node into a streamlined, aesthetically pleasing component of Zurich's transport network. Central Station had long been a heavily utilized junction, experiencing significant wear and tear over decades of service. The existing tracks had become extensively worn, necessitating a complete overhaul. The project entailed more than just replacing the old tracks. It involved significant modifications to the alignment and curvature of the tracks. The track alignment was adjusted, and the curves were widened, enabling trams to navigate them more swiftly and safely. These upgrades were crucial for improving the efficiency and safety of the tram network, addressing long-standing issues caused by the outdated infrastructure. In addition to track replacement, the construction project involved extensive modifications to the tram stop platforms. The 4 tram stop islands were either expanded or extended to accommodate the increased length of modern trams. The old shelter roofs were removed and replaced with 3 new waiting shelters designed to match the previous structure's aesthetic, while providing better protection for passengers. This redesign was intended to improve passenger comfort and ensure continuity in the station's appearance, aligning with Zurich's broader urban development goals. Parallel to the work at Central Station, the VBZ undertook additional track upgrades along the Limmatquai up to the route of Brunbruck area. During this period, tram services were rerouted to facilitate the necessary construction work. On the weekend of June 17 and 18, the tracks along the Limmatquai were replaced, marking the completion of the initial phase of the broader renovation project. This phase was crucial for setting the stage for the more intensive work that would follow at Central Station. The main focus of the renovation shifted to Central Station during the weekend of July 2nd. For this critical phase, Central Station was completely closed to tram and bus traffic from July 8 to 11. The scale of the operation was immense, with construction work taking place around the clock. At peak times, around 400 workers and 1,000 tons of machinery were on site, reflecting the scale and intensity of the effort required to complete the project within the tight time frame. During this intensive weekend, approximately 2,500 cubic meters of old pavement and concrete were demolished and transported away. This volume of material equates to about 167 truckloads. The demolished material was sent to recycling facilities, ensuring that the project adhered to sustainable practices. After the removal of the old materials, the ground was leveled and prepared for the installation of new infrastructure. The coordination of these tasks was critical, with demolition occurring simultaneously with the construction of the new track components. The ground was excavated to a depth of 70 centimeters, with a geotextile layer placed to separate the new fill from the original soil. A gravel layer was added on top of this geotextile, providing a stable base for the new utility lines and drainage systems. The new tracks were then laid, aligned, and welded into place. The precision of these tasks was vital for ensuring the durability and reliability of the new tram network. The welding work, which was essential for joining the track segments, was carried out predominantly at night. During the first weekend of the renovation, 171 welds were completed. After the base concrete was placed, the tracks had to be carefully supported to ensure proper alignment. In subsequent stages, the upper concrete was poured around the new tracks, and the surface was finished with new pavement. This careful and methodical approach was necessary to ensure that the new infrastructure met all required standards. By the end of the first weekend, shuttle buses began operating around Central Station to mitigate the impact of the closure on passengers. Managing the temporary detours was a significant challenge, requiring careful planning and coordination. Various tram lines were interconnected, and a new traffic network was constructed around Central to ensure that passengers could still reach their destinations. All construction work had to be completed by August 11th, as the street parade, a major annual event attracting hundreds of thousands of visitors, was scheduled for August 12th. To meet this deadline, a 24-hour operation was implemented for 5 weeks, demonstrating the project's urgency and scale. The tram stop platforms were expanded or extended to accommodate new tram compositions up to 43 meters in length. This extension was a significant improvement over the previous maximum length of 37 meters. The upgrade allows for the use of longer trams, which is essential to accommodate the increasing number of passengers using the tram network. The new trams being added to the VBZ fleet will also exceed 37 meters in length, reflecting the growing demand for public transportation in Zurich. The newly constructed waiting shelters were designed to fit the expanded platforms, and the ends of the stops and pedestrian crossings were lowered to ensure accessibility for all passengers. Despite these improvements, the constrained space at Central Station meant that the tracks could not be fully straightened, which resulted in some limitations regarding accessibility at the platform edges. The planners received an exception permit from federal authorities for these limitations, highlighting the complexity of the project and the need for flexibility in certain areas. Before resuming tram services, all new tracks and operational routes were thoroughly tested. On the Friday before the street parade, test runs were conducted using the full range of VBZ and Forchbahn rolling stock. These tests were crucial for verifying that the new infrastructure was functioning correctly and safely. Following the successful completion of these tests, tram operations resumed and the stops were reopened to the public. Since August 13th, traffic has returned to normal, with the renovated infrastructure providing a smoother and more efficient transit experience. In October, there were additional partial closures over 2 weekends for final pavement work. By the end of October, all construction work was completed on schedule. The successful completion of the Central Station renovation has allowed Zurich and the VBZ to enhance one of the city's most vital transport hubs, ensuring its functionality and efficiency for years to come.